Okay, see. For learning optimization technique, we need some basic to be clear, right? The topic name is optimization technique. Understood? In optimization means what? What do you know by optimization? Yeah. Yes, very good. Most suppose you want profit. If you are in loss, right? So for profit, you will get you want maximum profit, and if you are in loss, then you want minimum loss, right? So optimization means nothing. It is the best solution. Okay. So what should be the best solution to get the yeah, you can say to solve a problem? It's called optimization. In optimization, you will learn both maximum and minimum. How to find a maximum function, maximum value, and how to find minimum function. Okay. Yes. So before going this, first you understand what is function. Function. This is function in one variable, right? It means the function depend on only one parameter, that is x. Here function depend on two parameter. Sometimes function depends on three parameters. Parameters, let's suppose uh, this is quality and this is quantity, right? This is quality, quantity, and rating you can say. Understood? Yes. So this is two variable function. This is three variable function. It means your function depends on three parameters. Like your exam result depend on two parameters: your marks and your attendance. Right? Understood? Yes. So you have to identify with the help of function which you have to maximize or minimize. Okay. Okay. And after this, you will learn what is a graph of function. Second thing is graph of function. Okay. This is the graph of what? X square. Okay. So I show you two graphs. This is what? Graph of x square. This is something like a irregular graph. Okay. Now see, the most bottom point is this, right? Yes. And the most up point is this. Absolute maxima. This is called global maxima. Global means this is the maximum value and this is the minimum value. And this is what? Local minima. This is also local minima. This is local maxima, right? So these are local maxima. Understood? Yes. And what is this? Local minima. This is local minima. So all the bottom points gives minimum value, but most bottom point gives global minima. Understood? Yes. In first chapter, you will learn how to find local minimum and local maximum. In such second chapter, you will learn how to find global minimum and global maxima. Okay. And in third chapter, you will learn, is my global maxima is the best solution or not? Right? How can you verify that this is global maxima? Understood? Yes. After the, okay. So whenever parabola is given, in parabola, this is the most bottom point. Let's suppose you draw, when suppose you have a ball. When you roll a ball, it goes, it rolled like this, right? But after some time, it stay here, right? Yes. So you can see, whe- yes, you can see when a ball is rolled in a parabola shape, you will always get global minima. Understood? And this is called descent method. You will learn in second chapter. Yes. Right? So graph is very important for optimization. Understood? Second thing is differentiation. You must know some basic differentiation. Differentiation of x square is 2x. Differentiation of sin x is cos x. Right? Differentiation of ex is ex. I think you all know these things, right? And some power rule, product rule, quotient rule, chain rule, you all know, right? Yes. Now see the physical meaning of derivation. Physical meaning of derivation. Okay. If f dash x is positive, okay, it means the function is increasing. Understood? If f dash is negative, decreasing. If function derivation is zero, then not increasing, not decreasing. It is a turning point. Understood? It means at this point, the function moves from maximum value to minimum or minimum to maximum. This is the physical difference, right? Yes. For example, so at this point, function increases, right? It goes upside. This is turning point. So here slope is positive and here slope is negative. Understood? Yes. Now what is the significance of second derivation? Very good. Significance of f double dash x. Okay. If f double dash x is positive, okay. Yes. It shows local minima, not maxima. Local, I am talking about local, not global. If f double dash is negative, then local maximum. Okay. Yes. In this subject, you will also learn how to find partial derivation. Partial derivation is used when function contains more than two or more than two variables. Like, for example, this f of x means partial derivation of f with respect to x. F of y means partial derivation of f with respect to y. F x y means partial derivation of x when you differentiate with respect to y. When you differentiate with respect to y, you will get 0. Okay. Always remember one thing. Fxy and fyx is always same. And this is what? Two time derivation with respect to x then y, or y then x. Okay. Understood? Okay. What is stationary points and how to find this? What is stationary points? Yes, same thing. Yes, it can be both. It can give minimum value or maximum value. You cannot decide until unless you can check it. Okay. Yes. Understood, na? Okay. Okay. Now first we learn how to find local maximum, local minimum. Finding local minima and local maxima for one variable. Okay. So any function is given, right? Let's suppose this is y, this is given. Okay. First step is find f dash x. And for stationary point, put f dash x is equal to 0. Understood? Okay. Now find second derivation. Let's suppose stationary point is x1 and x2. Any, it can be two variable, three variable, right? If f dash x1 is equal to positive, then you will get local minima at x1. Understood? You will get local maxima at x2, right? Yes. So fourth step is f will be maximum at what? Yes, at x2. And f will be minimum at x1. Understood? Write this step, then I will explain one example. After this, I will tell you for two variables. Written? Okay. See this question. Find maxima and minima Question number one from your question paper. So you have to find maxima and minima. Here it is not clearly written which maxima, local or global. Okay. So what first step you will do? Yes, find f dash f, which is equal to 12 x square minus 36 x plus 27. Right? Always write for a stationary point, the point at which you can decide maxima or minima or saddle point, right? So for stationary point, put f dash x is equal to 0. Always write proper steps. Okay. Then f dash x is equal to 0. Means 12 x square. Take 3 common. Okay. Then how will you solve this? 9 4 the 36. 6 6 the 36, right? 9 and 4. Okay, let's check. Take 2x common. Minus 3 common. 2x minus 3. 2x minus 3, right? Only one stationary point you are getting, which is repeated 2 times, right? So this is the stationary point on which you have to decide it is maxima and minima, right? So for testing, for checking minima and maxima, what will you do? You have to do second derivation. For checking extremal value, this is called extremal value. Extremal value means you you are not sure that it gives minima and maxima. That's why you can say extremal. Extremal means boundary value, minimum value and maximum value. Okay. Okay. So second derivation will be 24x minus 36, right? At x is equal to 3 by 2. Oh, you got 0, right? 0 means stationary point is there, no issue. This is called saddle point. Yeah. At x is equal to 3 by 2. Yes. You can say x is equal to 3 is a saddle point. Saddle point means it gives nothing. You cannot decide at x is equal to 3 whether this is maxima or minimum. Okay. So this function has no minima and maxima value. You can say, sir, any function have minimum and maximum value. No, it is not sure because when a circle is there, you cannot say which value gives minimum and maximum. Okay. Yes. Understood? Yes. So I will tell you second question. Sorry, second method for two variables. I think it is very easy and you already know this, right? This part is fine. Okay. Finding. Yes. In whole chapter, in whole syllabus, you will learn how to find minimum and maximum. using different method. You there are one, I tell you, there are 20 to 25 methods are there in your syllabus. Okay, and all method you have to learn. Newton method, Fibonacci search method, right? Fibonacci search method, Hessian matrix method, initial steps method, right? So many methods are there, and you will learn everything. So now I tell you finding local minima and maxima for two variable. Okay, this is similar to as we have solved already in first one variable, right? Suppose a function given in two variable. Understood? First of all, find f of x. What is f of x? Partial derivation of f with respect to x, right? And f of y. Second step is for stationary point, put both equal to 0. From here, you will get what? Critical point or stationary point. This is also called critical points. Yes. You can do, but you have to show their steps. Critical point or stationary points. Okay. After this, okay, you got everything. Critical point, stationary point. Now, how will you check whether you are getting minima or maxima? You have to do double derivation. Yes. Find f double x means two time derivation of f with respect to x. Double y, right? And fxy also. Understood? Yes. Okay. And check this condition. Condition number 4. D is equal to ffx fyy minus fxy whole square. Understood? If D is greater than 0, you will get local minima. That's it. If less than 0, see, one important thing, you will get local minima only when D is greater than 0 and f double x is also greater than 0. If these two conditions satisfied, then you can say you will get local maximum. Sorry, local minimum. If D is 0, but fxx is negative, you will get local maximum. Understood? If D becomes if D less than 0, this is called saddle point. Saddle point means neither maxima nor minima. If D is equal to 0, test fails. Then we will apply other test. Okay? Yes. You can note this. Don't confuse. Okay? If D is greater than 0, this condition must also be satisfied. Both condition must be satisfied because in discrete mathematics you have learned if and is there. And means what? Both are compulsory, right? Write this, then I will explain with one example. Noting? Yes. After this, we will discuss for more than two variables, for n variables. That's why your subject name is optimization technique. You will learn the techniques how to find optimized value, how we opti optimize a function. Yeah, for one variable, two variable, more than two variable, for n variables. Okay, you will learn everything related with maxima and minima. Done? Take a photo of this so that when I explain, you can match there with the steps. Okay. Find the find stationary points and nature of x square plus y square minus 4x minus 6y plus 13. Okay. Understood? Yes. Now see. First we find what? Yes. Nature means we have to check whether this is maxima or min, right? Yes. First we find stationary point. So first of all find f of x, right? F of y. Okay. This is first step, right? Second step is for stationary points, which is also known as critical points. Put all the first order derivative is 0, right? 2x minus 4 is 0, which gives x is equal to 2. 2y minus 6 is equal to 0, which gives y is equal to 3, isn't it? So you have one stationary point, that is 2 comma 3, right? 2 comma 3 is the stationary points. Only one point is there and it always comes in pair. Understood? Only one stationary point is there and that is 2, 3. After this, but you cannot tell that this point give maximum and minimum value, right? That's why you have to also, now you are going to check. For checking, what you do? Double derivation. From here you get to fxy. Differentiate this with respect to y or differentiate with respect to x. Anything you can do. You will get what? 0. Right? Yes. Fourth step is find d. D is what? Understood? 2 into 2 minus 0 whole square. That is 4. 4 is greater than 0 and f of x is greater than 0. This is 2, right? If both are greater than 0, right? If d is greater than 0 and f of x is greater than 0, you will get what? No, no, no. Check there. Local minimum, right? Therefore, at 2 comma 3, f x y will be minimum, right? Yes, yes. Local maxima is when d is greater than 0 and f double x is less than 0. Okay, understood? I write here once again. If d is greater than 0, f double x is greater than 0, local minima. Okay, if d is greater than 0 but less than 0, maxima. If d less than 0, this is saddle point. And if d is equal to 0, test fails. Understood? This all 4 points you must remember. Now you can see both are greater than 0. First condition satisfied. Right? So f min 2 comma 3. It means in this function there is no maximum value. Understood? So, yes. Solve this. 4. Right? Yes. I think um, 0. I think you are getting 0. Simplify this. Yes. Okay. It means graph looks like this. At 0, it will give minimum value. And maximum you cannot decide. I think it goes up to infinity, right? Yes. Done? Yes. Can you try this? I have not told you how to find using Hessian matrix, but take this example and solve using the previous method. Okay. So it is not necessary that you will get explicit equation. Explicit means you will not get equation in the form of x only or in the form of y only, right? Sometime you will get a simultaneous equation. to solve these two equation anyhow. Anyhow means you can use a calculator, you can use manually, you can use elimination method. In this question, I eliminate x, which is equal to 4 minus y in second equation. And solving both, we get two stationary point, right? We have two stationary point. One is 4 comma 0 and 3 comma 1. Now we will do f double x, right? F double x is what? 1. F double y will be 4 minus 6y, and fxy will be 1, right? Okay. We will check on both point, both stationary point. Okay. First we check at 4 comma 0, right? At 4 comma 0, find d is equal to fxx, fyy, fxy whole square. So you know fxx is 1, fyy at 40. 40 means x is equal to 0 and put y is equal to, sorry, x is equal to 4, y is equal to 0, right? 6 into 0, you will get only 4, right? Okay. Put here fxx is 1 into 4 minus 1 whole square. That is 3, which is positive, right? And now you know d is positive, fxx is also positive. Both are positive. It means, understood? At 4 0, you will get minima, right? Yes, we will also try it. You have to check all the points, okay? Yes. Okay. Here fxx is 1, fxy. Put y is equal to what? 1. Check the condition. Minus 3. Sorry, minus 1. You know, if d is negative, d negative means this is a saddle point. Understood? Is it clear? Yes. 3 1 is a saddle point. Why saddle point? For minima and maxima, d must be positive. Yes. If d is negative, no need to check fx is negative or positive, because uh, I already written, if d is negative, it will give saddle point. Understood? So only one point is useful, which is 4 0. So f will be minimum at 4 0. Put the value of x is equal to 4 and y is equal to 0. Understood? Yes, it is constant. So for every cases, it is same. This will change. Why? Because it depends on y variable. Understood? Yes. Will you try one more question? Okay. Can I delete this? Okay. X cube plus Y cube. Wait. So, X cube plus Y cube minus 3x. So try this. Find the extremal value. Extremal value means maximum minimum. It can be 3 minus 3y, right? When you put 0, x square is equal to y. This is first equation, right? Put 0. 3y square minus 3x. Y square is equal to x, right? Solve these two equation now. Put x is equal to here or put y is equal to anything you can do, right? X square. What is y? Y is what? Okay, wait. X is what? Y square. So from here you get y raised to 4 minus y is equal to 0, right? Oh, yes. Anyhow you can solve y is equal to 1, y is equal to, right? If we put y is equal to 0, x will be 0 and x is equal to 1 on putting 1. Now how many stationary points are there? 2. And you have to check for both. You have to check at both stationary point. Now tell me at 0, 0 what you are getting? Minima, maxima, saddle point or test fail. Understood? Yes. And then also check at this point.
at 0, 0, I'm getting t is greater than 0, but sorry, t is less than 0 and fx is equal to saddle point.
At 0, 0 is the saddle point, right? Yeah, very good. And check for at 1, 1.
Local minimum. 0 and fx is greater than 0.
Minima.
Yes.
Okay, very good. Now also find minimum value of f. Put 1, 1 in the original function. So always write f is minimum at 1, 1. Yes. Okay. Understood? Yes. Find the extremal value of extremal means it can be both minima or maximum, right? X cube 3xy square 15x square. This is good question. Plus 72x. Try this. I think here you will get also two stationary points. Not two, four stationary points are coming. Check. Let's suppose this is f, right? So what is f of x? Plus 72, right? What is f of y? Fy 6xy 30y, right? For a stationary point, what will you do? Put both is equal to 0, right? I am solving without a step, but you can understand, right? So this is second step. So in first equation, take 3 common, right? Okay. From second equation, take 6 common. From second equation, you get what? Y. X minus 5, right? Y is equal to 0 or x is equal to 5. Understood? This is not in pair. Don't write 5 comma 0. You got different values. Okay? Yes. But when you put y is equal to 0 here, whatever you get x, that make pair. Okay? Yes. Here you write at y is equal to 0, x square minus 10x plus 25, 24. 6 4 ja 24. I think 36 minus 31. Yes, one root is 6, right? 116 minus 16. 4 is right. So from here you got two stationary point. 6 comma 0 and isn't right? At x is equal to 5. Also check for this point also. Minus 25 is equal to 1, right? So from here you get plus 1 minus 1. 5 comma 1, 5 comma minus 1. How many stationary points are there? Yes. And at each point you have to check the condition, right? 4 stationary points. Now tell at 6 0 what you are getting. Understood? Yes. F double x will be 6x minus 30. F double y will be 6x minus 30. xy will xy will be yes, yes, with respect to y. With respect to x, you will get 6y, right? Now at 6 comma 0, f double x will be 36 minus 35, which is positive. F x y will be 0. F y double y will be 5. D will be so 5 5 the 25. Both are positive, right? 6 0 gives local minimum. Now check for this point, and this point. At 4 0, what you are getting? D is positive and R is negative, right? At 40. F y y minus 6. Okay. F x x is minus 6 also. 4 comma 0. Let's check. No. Yes. D is positive, right? Yes. Maxima. You will get maxima. Don't think you got a maximum minimal. We will not check for this point. You have to check every point. Understood? Yes. Check for 5 1 and 5 minus 1 also. Tell me at 5 1 what you are getting. D is negative means test fails, right? No, sorry, saddle point. Saddle point means this point will not give minimum maximum. And check for 5 minus 1. At 5 minus 1 also you are getting negative, right? Yes. Understood? Yes. Now we will explain this problem. Stationary value means extremal value. Maximum, minimum. Okay. So first of all, let's suppose this is what? Understood? What is fx? Sin y is constant. Use product rule, right? Sin a cos b plus cos a sin b. Understood? You got one thing. What? This is the formula of. No, no, no. Sin a cos b plus cos a sin b. Very good. So in short, you can write sin x plus b, which is equal to 2x plus y, right? Similarly, tell me what is fy. U v plus vu, right? This is also in above form. 2y plus x. Isn't? For a stationary point, what will you do? Yes, for stationary points, put both equal to 0. right? How will you solve this? Okay. See, either sine is equal to 0, right? Understood? Okay. Sine y is equal to 0. So it is 0 when y is equal to 0, right? If y is equal to 0 or y is equal to pi, right? Because sine pi is 0. Okay. Is it clear? Don't try it n pi because this is for general case. We will solve for one stationary point or two stationary point. Okay. This will be 0 or pi. Understood? Yes, yes. See, when y is equal to 0, x will be 0, right? And when y is equal to 0, put here, what will you get? X will be pi, right? Put y is equal to 0 here. Wo- Yes, one time you will got 0 and one time you will got pi. So 2 points you have 0, 0 and pi 0, right? Okay. When y is equal to pi, right? Y is equal to pi. Then 2 pi x will be pi also. Okay. Pi comma pi and 0 comma pi. And see this 2x plus y is equal to pi, x plus 2y is equal to also pi. Solve these two equations and tell me what is the value of x and y. Yes. So solve this, multiply 2 on both sides. So from here you are getting x is equal to pi by 3, right? Understood? Y minus 2 pi minus pi is pi. X is equal to pi by 3. 2 pi by 3. Y will also pi by 3. Understood? So these are the stationary point at which you have to check minimum maximum. Understood? So first you tell me at 0, 0, what you are getting. How many stationary points are there? 5 stationary points are there. Okay. Two sin A cos B. Sin A plus B. Sorry, 2 sin A cos B. Yes. Sin A plus B plus sin A minus B. See, F double x. When you do with respect to x, sin y is constant, right? No need to expand. Okay. You will get 2 cos 2x plus y. That's it. Okay. 2 cos x. 2x plus y sin y. And what is f of y? 2 cos x plus 2y sin x. Okay. And what is f x y? When you do with respect to y, you will apply product rule, right? Here you got confused. No, no need to apply here formula because you have to put directly the value of x or y. Okay. Because when you expand this, you will get larger value. Right? This is already in simplest form. Now do with respect to y. Sin y. 2 cos 2xy cos y. Here you can use formula which, but here 2 sin a cos b plus sin a cos b is there, right? Again, formula cannot be applied, right? If formula is not applied, then put directly. First you check at 0, 0. At 0, 0, fx will be sin 0 is 0. The whole thing will be 0, right? If fx x is 0, no need to check further. Why? Because for maxima and minima, fx can be negative or positive. Not understood? If fxx is 0, then d will be d will be negative always, which represents saddle point. At check pi 0. Okay, so 0 pi will also give saddle point. Pi 0 also same, right? Because y is 0. This is also a saddle point. Understood? Yes. So 2 points are not useful. You cannot cut, but you have to show there. Right? Now check for 0 pi. x is 0 and y is pi. Again, if y is pi, sin pi is 0. Sin pi is what? 0. This is 0. Again, this is a saddle point, right? 0 into anything is what? 0. Then you will get fxx is 0. If fxx is 0, then no need to check d, because if fx is 0, d will always negative. Understood, na? And here x is equal to pi and y is equal to pi. When you put y is equal to pi and x is equal to pi, you will get fxx 0 and fyy 0. Right? If both are 0, d will be negative. This is also a saddle point. I think only one point is very useful. Yes. At pi by 3 and pi by 3. So 2 sin pi by 3. Right? 2 pi by 3 plus pi by 3. Cos pi by 3. 3 pi by 3. Cos pi, right? Pi by 3 means what? 60 degree. Sin 60 is what? Yes. And this is negative. Minus root 3. Fyy will be sin 60 cos. I think you will get same thing, right? Both negative. And what is this? Minus root 3 sin pi is 0. This is 0. So all values are root minus 3. And check. This is negative. Find the value of d. What is d? Root 3. Root 3 means 3 minus root 3 square. 0. Yes. Yes. Hmm. Sin A cos B. Okay. 1 minute. Here 2 is not there because you are differentiating with respect to x. So root 3. Root 3 by 2. This is root 3 by 2. So 3 minus 3 by 4. 9 by 4. D is positive. D is positive and this is negative. It means maximum value you will get. Understood? So you will get maximum value. Understood? Hmm. Okay.